Okay, so let's practice some examples finding the general antiderivative or the indefinite integral. And be sure that you're checking your answers by taking the derivative. So for the first one, the integral of 1 over 4x squared dx. So first thing we need to do is we need to rewrite this into a form that we can use our power rule to find this integral. So let's rewrite this as the integral of 1/4 x to the negative second power. So notice the way we're rewriting these is the same way we rewrote functions to find the derivative originally. And then don't forget you have to have your dx there. So now we know we can pull out the 1/4 from the integral. So this is 1/4 times the integral of x to the negative second dx. And then by our power rule now, this is going to equal to 1/4. So we add 1 to the power, so x to the negative second power plus 1. So think about what we did with derivatives, right? We subtracted 1 from the power. Well, we're undoing differentiation. So we add 1 to the power. And then, because when we brought the power down, we technically multiplied by the power with derivatives. So we're going to divide by the new power for antiderivative. So divide by negative 2 plus 1. So our power. And then always add on a plus c because we could have any function with a constant. So then let's clean this up. So this is 1/4 x to the negative first power divided by negative 1 plus c. So this is 1/4 times negative 1 over x plus c, which then just gives us negative 1 over 4x plus c for our antiderivative. To check this, so we want to find the derivative of negative 1 over 4x plus c. So if we think about that, that's going to be the derivative with respect to x of negative 1/4 x to the negative first power plus c. So to differentiate that, bring down the negative 1, right? So that's negative 1/4 times negative 1 x to the negative 1 minus 1 plus the derivative of a constant is 0, right? So then this gives us positive 1/4. So negative 1 times negative 1/4 is positive 1/4 x to the negative second power plus 0, so that can just go away, which is 1 over 4x squared, which was our original antiderivatives integrand. So that was our original integrand, so it does check. All right, let's look at number 2. So the integral of 3 over square root of x dx. So first off, let's rewrite this. So same way we would rewrite this as if we were taking a derivative. So 3x to the negative 1/2 power dx. We can pull that constant out of the integral. So this is 3 times the integral x to the negative 1/2 dx. And so then that is 3x to the 1/2 plus 1. Or sorry, negative 1/2 plus 1 over the new power. So x to the, or sorry, over the new power, so just negative 1/2 plus 1 plus c. So this becomes 3x to the 1/2 power over 1/2 plus c, which then cleans up to be 6 square roots of x plus c. And make sure you go back and check it. So make sure you check it by taking the derivative. On the test, you will have to check these. So make sure that you're checking them, because if you don't check it on the test, you're going to lose some points on each one. All right, example 3. So the integral of x plus 3 to the second power dx. So this looks like something, if we were differentiating it, we would use the chain rule on, right? So we're going to get to something that's analogous to undoing the chain rule. But we don't know how to undo the chain rule yet. So we have to start out just by rewriting this. So to rewrite this, in this case, we want to square out x plus 3 to the second power. So we know if we square out x plus 3 squared, that's going to equal to x squared plus 6x plus 9. So we can rewrite our integrand then as the integral of x squared plus 6x plus 9 dx. And now let's do it piece by piece. So x squared becomes x to the 2 plus 1 over 2 plus 1. Plus 6x to the 1 plus 1. So remember, if you don't see a power on the x, assume it's 1, right? Over 1 plus 1. Plus, and the integral of 9, that's 9x to the 0. So that's going to become 9x plus c. And so cleaning this up, we end up with x to the third over 3 plus 6x to the second over 2 plus 9x plus c, which then is equal to 1/3 x cubed plus 3x squared plus 9x plus c. And so now make sure you go back and check it. All right, let's look at example 4. So the integral of 2 cosine x plus 5e to the x dx. So take it term-wise. So this is going to be 2 times the integral of cosine x. So antiderivative of cosine x is sine x. So we have 2 sine x plus 5 times e to the x. So the antiderivative of e to the x is e to the x plus c. And so then we knew this, so just getting rid of our parentheses, rewriting this, so 2 sine x plus 5e to the x plus c. And that's our antiderivative. That's as far as we can simplify. So make sure you go back and check it. All right, so example 5, the integral of sine squared x plus cosine squared x dx. So before we can do this, we don't know how to integrate the sine squared yet, right? But if we look at that, we know that sine squared x plus cosine squared x equals 1, right? That's our Pythagorean identity. So let's rewrite this integrand. This is really the same thing as saying the integral of 1 dx, right? Which then just becomes x plus c. So let's do one more example. So the integral of x squared plus 1 over x dx. So taking this term-wise, piece by piece, same way we differentiate, right? So the antiderivative of x squared becomes x to the 2 plus 1 all over 2 plus 1, right? So add 1 to the power, divide by that new power, plus the antiderivative of 1 over x, we know is going to be natural log absolute value of x. Don't forget the absolute value on these. It's very important because we don't know if x is less than 0 here, right? What would happen if x is less than 0? Then it's not going to be in the domain of natural log. So we have to account for that by having the absolute value inside our natural log of x. So it's going to be natural log absolute value of x plus c. And then simplifying this, we end up with 1/3 x to the third power plus natural log absolute value of x plus c. All right, so now make sure you go through and work examples 2 through 7 in your textbook, and then try the homework for section 5.1.